Okay, so we'll get started. This is what we'll go over today. The homework that I gave you on the LCM, the GC, the lowest common multiple and the greatest common factor, and these other topics. And we'll start after we go through our homework. Then we'll go to our new topic, which will be on fractions. Now we will cover fractions in starting this session and continue with fractions on Thursday in our next session. All right. Okay. Now let's get started. We do a new share and bring up the homework. Maureen, did you do any of your homework?
We do some.
Okay, good.
For
Okay.
my hand that I usually write and thing with,
Uh-huh.
I was waiting for the doctor to call me today, but I didn't call yet. Got to go and get X-ray on it. It's like it when I get in therapy on it, it swells, it hurts me so bad.
Oh boy.
So I called him, so he said send me a paper to go and get an X-ray, and then after MRI, but there was a call today, but it's still daytime, so I still got to wait.
Okay.
And it's very hard sometimes to get on the computer, even to
Yeah.
touch the little button.
Yes.
So much pain in my hands of pain.
Oh my goodness. Yeah, that can be really hard, I know.
Tell me.
Yeah, and the least little movement, you have the pain, right?
Yeah.
Now, Maureen, on number one, the factors and multiples. What answers did you get for number one? Did you get the answers you see here?
Answers I get
What answers did you get?
which of the following numbers
Numbers are
are
multiples of 6. In other words, you can multiply by 1, by 2, by 3, by 4, by 5, etc. So what answers did you have?
I get A,
Okay, what else?
B,
B, what else?
as E.
What number can you multiply by 6 and get 32?
32?
Yeah, C is 32.
Yeah.
So what number can you
Oh,
multiply by 6 and get 32?
well, 6 will get 32.
Yeah. What number did you multiply by 6 to get 32?
I didn't do that.
Well, you said C was one of your multiples of 6.
No. I said A, B.
B, and what else?
And E.
That's it. A, B, and E, correct.
Yeah.
Because 6 times 2 is 24. 6 times 3 is 18.
Yeah.
And 6 times 6 is 36. But
Yeah.
C and D, you cannot get by multiply by, because 6 does not divide into 32 with an integer or a whole number, and 6 does not divide into 16. Okay, very good. Now, number 2, which of the following is not a factor of 15? What did you get? What were your answers? Not a factor. I'm sorry, Maureen.
I get D.
You got D. That is correct, because 4 cannot divide into 15s, because 3 into 15 is 5. 5 into 15 is 3. 1 into 15 is 15, right? So far you're doing good, Maureen. Wonderful. And 15 into 15 is 1. So the answer is D. Okay, let's go to the next one. Okay, how many factors does 44 have? How many did you get?
I get B.
What did you get?
B.
What are the factors of 44 that you came up with?
How many factors does 44 have? I put B.
Factors of 44. You said there are 4 of them. Okay. So
no, I said B.
Yeah, you said B, which is 4, right?
Yeah.
Okay, tell me the factors of 44. Give me the numbers you can multiply and get 44.
Yeah. I got 41 number, that is B4.
You got 4, what are they? What are your factors?
4 into 44 is 11, right?
Okay,
Okay. Then we got 6. Then we
six,
got 8.
6 goes into 44.
No, no 8, no 7.
7
No,
goes into 44.
no.
So tell me 2 numbers you got. You can multiply and get 44. You said what? 4 and 11, right? 4
Yeah.
and 11. Anything else?
No.
There are no other numbers you can multiply and get 44?
1.
Yeah, 1
1.
times 44. Other than 1. What
Okay.
about 2? Isn't 2 times 22?
Yeah.
It's 44, right?
Uh-huh.
So 2 times 22, right? Anything else? You can multiply and get 44.
Okay. 2, 22 is 44. No.
Then no,
That's 44, but I have said 1 already, right? So,
well, 1 times 44.
uh,
Well, 1 times 4. Well, let's put 1. Because remember I said you put the 1 and then you put the 44, the number itself. And then you put in between, correct? So you always, with your factors, you start it with 1 and you end it with the number that you're factoring. So you put 1, 44, and in between you got 2 times 22, and you got 4 times 11. How many factors is that?
4 to 11 is 44.
No, how many factors? Oh, these are all the factors of 44. How many do you see?
6.
6, right?
Yeah.
So your answer would be what?
Oh, I see.
So what would be your answer, Maureen?
See.
C, that's it, because there's 6. So your answer is C. Factors are 1, 2, 4, 11, 22, 44. You got it?
Yeah. 6.
Remember I said for your factors, Maureen, you always start with 1 and you end with the number that you factor in. So you can put in the 1 and the 44. Now you came up with 4 more, right? Because you said B, but if you have these 4 plus the 1 and the 44, that's a total of 6.
Uh,
So there's 6 factors. Answer C. You got it?
yeah.
Always start with 1 and end with the number that you're factoring. Okay. All right. Now let's go to number 4. Which of these numbers are multiples of both 3 and 17? What did you come up with?
3 and 17.
Yeah, 3 and 17. Which of these numbers are multiples? In other words, you multiply the number by 1, then by 2, by 3, by 4, etc. So which one of these numbers are multiples of both the number 3 and the number 17? What did you get?
I get, okay, I do 3. I do 1, right?
Well, what was your multiples of 3?
3, 12, right?
Well, you're leaving out something, Maureen. Okay, so let's write them down here. Multiples of 3. Now give me your multiples. What's the first one? 3 times 1 is what?
3.
And then what's the next one? 3 times 2,
Oh, 3 times 2 is 6.
6. Okay, then what's the next one? Keep going.
9. 3 times
9,
3 is 9.
right? Okay.
And
Next.
9 trees is 27.
Wait, no, Maureen. Remember, you're multiplying by 1, 2,
Yeah.
3,
2,
4, 5. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. Okay. 4 times 3
4
is
times
what?
3 is 12.
So you remember you're adding 3 each time. So what's the next one?
3 times 4. 3 times 12 is 36.
No,
No,
Maureen, you're adding 3 each time. So you
what?
said 3, 6, 9, 12. What's 12 plus 3?
15.
15. So add 3 each time. What's the next one?
15 and trees, 18.
That's right. And the next one?
21.
21. Okay. The next one?
24.
Okay. Keep going.
27.
Okay. Next.
30.
30. Next one?
33.
Okay.
36.
36. Next one?
39.
39. Okay. Next one?
41.
Uh,
42.
42. Okay. Next one?
45.
45. Okay.
48.
48.
51.
51. And the next one?
54.
54. Next one?
57.
Okay. 57.
60.
Okay. 60.
63.
63. And the last one?
7.
66. Right. No, 3. You're adding 3s.
Yes,
Now, so because I wanted to
63.
get to the
Or
biggest number here, which was
66.
68. Okay, now let's say multiples of 17. Multiples
You
of,
got 63, 64, 65, 66. It can't be 67, 68, can't be 69. Okay, yeah.
right, it's right? Okay,
Yeah.
multiples of 17. So that's multiples. Okay, let's do multiples of 17. So give me the first one, Maureen.
1.
No, you're multiplying by 1.
Yeah.
So 1 times 17,
It's 17.
17. Okay. What's the next one?
2 times 17.
Yeah, oh, 17 plus 17. How much is that?
34.
34. Okay, what's the next one?
51.
51. Now we can stop here because
Yeah.
we have a 51 in our multiples of 3, right? So which of these are multiples of both 3 and 17? You have a 51 here
Uh-huh.
and you have a 51 here. So
Yeah.
what would be your answer?
51.
That's it. A
Yeah.
or B or C. Okay.
Yeah.
Answer A. All right. Answer A. Because when you got 51 here, you say, okay, I've got a multiple up here, 51.
Uh-huh.
So that's the smallest one of this string of multiples. So the multiples of both 3 and 17 or 51.
Mhm.
All right.
Uh-huh.
Okay. Did you have that one correct, Maureen?
Yeah.
Okay. Yeah, because remember now you take the number that you find in the multiples of and multiply it by 1, 2, 3, 4, 5. Or you could just add the number like 3 and then add 3 and then add 3. 9 and 3 is 12, 12 and 3 is 15, etc. 17, 17 and 17 is 34, and 34 and 17 is 51. right? Let's go to any questions on that, Maureen. Number 4.
No. Uh-uh.
So you know the difference with the multiples.
Yeah.
Yeah, factors, just to review, factors, you start with 1, end with the number that you factor in, and then get the factors in between. For the multiples, you multiply 1 by the number and then keep going, each time adding 1, then 2 by the number, then 3 by the number, then 4 by the number, etc. All right. Okay, let's go to number 5. Which of the following numbers are common factors of 8 and 24? Okay, so let's do this. Okay, Maureen, you tell me factors of 8. What are factors of 8?
1,
Okay, 1. Well,
2.
remember I said you could put 1 and then you put what you factor in 8. So let's put in between. So you said 2, okay, because 2 times 4 is 8. What else? We've got 8. Anything else?
I don't think so.
What about
1 to
4?
the 8.
What about 4?
Oh yeah, 4 times 2 is 8.
That's right. 4 times 2 is 8. So, and then we said we had 8 as the last number. So 1, 2, 4, and 8. Okay. Now let's do our 24 and see if there are any factors in common, because we're looking for common factors. So factors of 24. Okay.
1.
Okay, that's right. We know we have 1, and then we know we have 24. So I put 24. So let's put in between. What else? What's the next one after 1?
After 1 is 2.
That's right. 2 times 12. What's
Yeah.
next?
Let's see, 3 times 8.
That's right. Very good. 3. So 3 is a factor. Anything else?
Let's see, 3 days is 24. One, two, three.
What else?
No, 9 else.
What about 4 times 6?
Huh?
4 times 6 is 24.
Oh, yeah.
So there'll be a 4,
Oh,
right?
yeah.
Okay. And there'll be a 6.
6 times 4 is 24.
That's right. And what else? And then 8. 8 times 3 is 24, right? Okay. And what else?
8 times 3 is 24.
12 times 2 is 24.
12
So
times,
we would
yeah,
have
12 times 2 is
12, right?
24. Oh.
Okay. So what factors do you see in common between 8 and 24? What are they?
3, 8, and 24.
It says, which of the following numbers are common factors of
Yeah.
8 and 24? So which ones are in common with these two groups? Which
8.
one? No. Which factors do you see in the two groups, 8 and 24? Okay. 8 says 1, 2, 4, 8.
Yeah.
What about 24? Does it have 1, 2, 4, 8?
1, 2. We got 1, 2, 4.
Yeah, 1, 2, 4, 8. So it has those factors in common, right?
Yeah.
Now, okay, so what would the answer be here?
8.
So which of the following numbers are common factors of 8 and 24? So the answer would be what?
Oh, it's
There's more than one.
8. Or it'd be, let me see, answer would be 2.
No, remember
No,
you got
1,
A, B,
5.
C. No, A, B, C, D, E, the choices.
Yeah.
So which alphabet there has 1, 2, 4, and 8?
1, 2, 4, 8.
Yeah.
What D, C, and B.
What else?
It got 4, right? Is B,
Okay, so we have B and what?
C,
C. Okay.
D,
D.
8,
E.
E.
Give me the letter E, right? B, C, D, and E. You don't see 12 as a factor of 8. It's a factor of 24, but not of 8. So the only one you would leave out would be A, because 12 is not a factor of 8 and 24. It's only a factor of 24. So your answers would be B, C, D, and E, because the factors they have in common are 1, 2, 4, 8. Got it?
I do that, but then you wait the long way.
Huh?
You wait the long way, but you wait the short way.
Well, you could do it without you could do it without the way I went here. You could eliminate the 12 because 12 is not a factor of 8, and then all the rest would fall.
I know. That's how I do mine.
Yeah. Well, that's right. Well, once you do enough of these, you don't have to put the factors. But I do it like this for those that are just learning and they don't know how to pull out the factors. But you can do mental math and get factors of numbers like 8, some of the smaller numbers. You can definitely, because all you need to do is pick out numbers you can multiply to get that number, right? And 4 times 2 is 8, 8 times 1 is 8. Okay, so you can pull those out pretty quickly. But there's no 12. So that means this one is not a common factor because 12 is not a factor of 8. Okay, all right. Okay, Maureen, did you do number 6? Which of the following numbers are not multiples of 9? Now, this one you could also do without having to actually do the least common multiple, right?
Mm-hmm.
Okay, so which of these numbers are not multiples of 9? Least common multiple of 9, or what? What are the least common multiples of 9? 9 times 1 is what?
9.
9. What's the next
9
one?
times 2.
2 is what?
18.
18. 9 times 3.
9 times 3 is 27.
Okay, you're adding 9 each time. 27 plus 9,
Oh,
right?
36.
36. 36 plus 9.
36 and 9 is 44. No, 45.
45.
Okay.
Okay, so which of the following are not multiples of 9? Well, 18 is a multiple, 27 is a multiple, 3 is not a multiple, 45 is a multiple, and 9. So the one that's not is which one?
C.
C, that's right. So answer C. Answer C. Okay, because C is not a multiple. Okay. In other words, when you take the 9 and multiply it by 1, the lowest number you get is 9. So 3 is too small, right?
No,
Okay. Okay. Did you have that one right, Maureen?
yeah.
Okay, very good. Okay, let's go to number 7.
I don't know if I understand this right anyhow.
Oh, what? The prime factors?
Yeah.
Well, remember, what are prime factors? Numbers that can only be multiplied by themselves and 1, right? So what are the prime factors of 22?
11. No. 1. 122 is 22, right?
Okay,
That would get
no,
something.
prime factors. The numbers that can only be multiplied by themselves and 1. So, okay, factors of 22. So what are the factors of 22?
1.
Not 1 now, because we want numbers that can be multiplied to get 22, but they cannot be factored. In other words, they are primes.
2.
So it would be 2 and what?
11.
And 11. Now, 2 and 11 are prime numbers, right? Because 2 cannot be factored other than 2 and 1. And 11 cannot be factored other than 11 and 1. So when you factor 22, you get 2 prime numbers, a 2 and an 11. That's what they mean by prime factors, numbers that can only be factored into themselves and 1. And 2 can only be 2 times 1. 11 can only be what? 11 times 1. So the prime factors, so what would be the answer for number 7, Maureen?
Oh, B and E.
B and E, very good, okay. Answer B and E. So remember your prime numbers, numbers that can only be multiplied by themselves and 1, right? So when you factor 22, like you said, you got 2 and 11. 2 is a prime number, 11 is a prime number. So the prime factors are 2 and 11. So you look at your list here and you have 2 as E and you have 11 as B. So answers B and E. Questions? Because that one you said you didn't understand. Now, Maureen, Maureen, just remember that your prime numbers are your numbers that can only be multiplied by themselves and 1. Now, just to give you a review, okay. 3, is that a prime number? Yes or no?
3?
Yes.
Yeah.
That's right. It is a prime number. What about 6?
No.
6 is not a prime number because 6 factors of 6 are what?
2 and 3.
3 and 2. Okay, 6 factors. Okay, or 3 and 2. Okay, so I won't say 6 factors, say factors of 6 are 3 and 2. So it's not itself and 1. So 6 is not a prime. It's called a composite number. But 3 is a prime number because it can only be factored into itself and 1, 3 times 1. Okay, let's keep going. Which of the following are multiples of 10? Maureen, did you get that one?
I think so, I'm sure.
What did you get?
I get, I said 10 twos is 20, right?
10 twos are 20, 10 threes are 30, 10 fours are 40. So you can just keep going, 20, 30, 40, 50, 60, 70, 80. So which ones are not multiples of 10?
E and C.
That's right. Very good. Answers Okay. C and E. Very good, because you can't get 15 and 55 by multiplying by 10. Okay. So you can just run them down 20, 30, 40, 50, 60, 70, 80, etc. So 15 and 55 is not in that string of multiples. Okay. Let's keep going. This should be. Oh, no, I'm sorry. Which ones are multiples, Maureen? Not are not. Which ones are multiples? I'm sorry, I read it to you wrong. It says, which of the following are multiples of 10? So it's only the ones like 20, 40, 60, 80, etc. So it'd be A, B, and D. Okay. If it had said are not multiples, then the answers would have been C and E. Got it?
Mhm.
Okay. All right. Now let's find our LCM, lowest common multiple, and the greatest common factor for these numbers. Now, first you get the factors, and then you say which one are in common, and then which are greater. So 16 factors are 1, 2, 4, 8, 16. See, we put the 1, we put the 16, and we put the ones in between. 8 times 2 is 16, 4 times 4 is 16.
Mhm.
Then 28, we have 1, 28 in between. 4 times 7 is 28. 2 times 14 is 28.
28.
Now, what do they have in common? 1, 2, and 4. You see in both lists, right?
Yeah.
Now, which is higher of the common factors, 1, 2, and 4? The highest is 4, right? So the
Yeah.
greatest common factor is 4.
Oh.
Okay. Did you do that one, Maureen?
No, I didn't do that.
Okay. So you have to list the factors for each number, and then the ones they have in common, the ones you see in both lists. That's 1, 2, 4, 1, 2, 4. Then you look in the list, say, what's the highest number there? The highest is 4. So the greatest common factor is 4. Now, when you do the multiples, you multiplying by what? 1, 2, etc. So 16 times 1 times 2 times 3 times 4 times 5, 6, 7. And you get 16 times 1, 16. 16 times 2, 32. 16 times 3, 48. 16 times 4, 64. 16 times 5 is 80, all down the line, right? Now, that's for the 16. For 28, 28 times 1 is 28. 28 times 2, or just add 28 and 28, 56. 56 and 28, 84. 84 and 28 is 112. So you see what the multiples that match are 112. So the least common multiple is 112. Got it, Maureen?
Yeah.
Okay. Now let's do the next one. I think we had 3 of these. Okay. 9 and 15. We put the 1, we put the 9, and
Right.
then in between is a 3, because 3 times 3 is 9, right? Okay. For 15, you put the 1, you put the 15, and between 3 times 5 is 15.
Yeah.
What do they have in common, Maureen? What are the common factors?
1, 3, and 5.
No, you don't see a 5 here.
You doing 9. Oh,
Yeah,
1,
9
3,
doesn't
and
have a
9.
factor 5. So
1, 3, and 9.
no, what are the common factors? What do you see that's the same in both of these lists?
3.
The same.
Yeah, the same is 3.
No. 1, 3, 1, 3.
1, 3. Yeah.
So it's 1 and 3 are the common
Yeah.
factors. And what's the greatest of these? What's bigger, 1 or the 3?
3.
3. So the greatest common factor is 3. Okay. And then when you do the multiples, 9 times 1, 9, add 9. So you get 9, 18, 27, 36, 45, 54. Then 15 times 1 is 15, times 2 is 30, times 3 is 45. And you see what? The least common multiple is 45. Got it? Now, 7 and 11, both are prime numbers, right?
Yeah.
So the factors are 1 and 7,
7.
and 11, 1 and 11. So the greatest common factor is 1. So the common factors that they in both lists is 1. So the greatest common factor is 1.
1.
Multiples, 7 of 7, 14, 21, 28.
35.
And what about 11? 11, we have 11 times 1, 11 times 2, 22, 33, 44, 55, 66, 67. What do you see in both lists?
Okay.
What number do you see in both the multiples of 7 lists and the multiples of 11 lists?
77.
That's it, 77. See, 70. So your least common multiple is 77. So Maureen, you can go through these and do multiples and factors, right?
Yeah.
Okay.
So,
All right. Well, just remember your factors. You always start with 1 and end with the number you factor in, and then find the ones in between. Okay. And for the factors, you taken the number and you multiplied it by 1, then by 2, then by 3, then by 4, then by 5, etc. Then when you do it for 2 different numbers, then you see what number you see in both lists. And like you said, 77. Now we looked at some properties, commutative and distributive. Commutative, and we said that's moving about, right? So 4 times 5 is the same as 5 times 4. So that's a what? Commutative property. So answer A.
Yeah.
Now distributive property is where you really you distributing the multiplication, the addition over the multiplication. So the -9 times minus D plus B is the same as -9 times minus D. Let me just write this here. So this is the same as -9 times minus D plus -9 times B. In other words, that -9 applies to everything in the parentheses. So you multiply it by the minus D and you multiply it by the plus B. But a -9, what's a minus time a minus, Maureen? What sign?
A minus and a minus is a minus.
Multiplying?
Huh?
I said multiplying, not adding.
A minus and a minus is a plus.
That's right. A minus times a minus is a plus. Remember, multiplication, division, like signs give you plus, unlike give you negative. So a minus times a minus gives a plus. A plus times a plus gives a plus. But a minus times a plus gives a minus, or a plus times a minus gives a minus. So this -9 times minus D will give you a plus 9D. That's the default. so you don't have to put the plus. And then the -9 times a B gives you a -9B. So that would be the answer. 9D minus 9B. All right. So that's the distributive property.
Oh.
You have a multiplication times something in parentheses, and you apply that variable or digit outside the parentheses to everything within the parentheses. Now, Maureen, which of these are the same? 2 times 3 times 9 times 2. Which of these is the same? This commutative property. Which of those are the same? And how could you find out?
Yeah. I would say A.
That's correct. Very good. Because if you it's not C says plus, but the asterisk is up is a
The
multiplication.
multiplication,
That's right.
yeah.
So it can't be C. And these two numbers, B and D, if you multiply 2 times 3, you get 6. 6 times 9 is 54. 54 times 2 is 108. So that does not match B, and it doesn't match D. And actually, when you see A has the same numbers that's in this expression, except we move them around. And that's what
Yeah.
commutative is, commuting, moving
Yeah.
things around. Okay. So answer is A. Okay, I think I have it here. Answer A, because if you multiply, like I say, you get 108. So it cannot be B or D.
Mm-hmm.
Okay, I think that's the end of the homework. Maureen, any questions on the homework?
No.
Okay, so you're ready to start with fractions, right? Ready to start with fractions? Maureen, what is a
Okay.
fraction?
Oh boy. I know it's a fraction, but I can't remember right now. I ran into faults in the but I know a fraction is like 1/2.
That's right, 1/2.
3/4.
That's it, right? Numerator over denominator. But it is a number, right? New share. Now let me just go to, I think I put it up. Okay. Remember when we did the real number diagram? Can you see it? The real number
Yeah.
diagram?
Yeah.
We had fractions in there, right? As a rational number can be an integer or a fraction. So that's what we're looking at now, fractions, right? So you gave me some examples of fractions. So let's go to new share. And I want to bring up, let's see. Now, we use fractions in the real world. People don't think of it that way, but we do. And I put some examples here. Splitting a bill while eating at a restaurant. Maureen, how do you use fractions for splitting a bill?
Half and half.
Hmm?
Well, if I was splitting the bill and it's 2 people, it'd be half and half.
That's right. You're right. If it's 2 people, you would split it in half. Say the bill comes to $20. Say half of 20 is 10. So each person pays 10. Or if the bill comes to $85 and there's 7 people, how do you split it?
Into 7.
That's right. You split it into 7. So 1/7 of that amount will give you what everybody should pay. Of course, what people do is they add in the tip,
I didn't take.
the gratuity, and then do that. Okay. Another way in the real world, calculate the discounted price of an object on sale. How do you use it for calculating the discounted price?
Okay.
Give me an example of how you use fractions for calculating the discounted price.
Okay, like F is like, I can take, sure for F is $100 and it's 20% off the $100, right? It'd be
Right.
$80. Yeah,
Yeah, you take, well, 20% is 1/5, right?
yeah.
And 1/5 of 100 is 20, and 20 from 100 is 80. So it's absolutely right. How do you use it with following a recipe?
Must see. That's a good one. Recipe.
How do you use fractions following a recipe?
Let's see. If we're doing the recipe. Probably cereal.
How? Give me an example.
Like, if it's like 20 cups and you only want to use like 1/4 of 20, sure.
No, keep going. You're right. If you were making a recipe and you needed 20 cups and you wanted to make 1/4 of that recipe, you use 1/4 of every amount. So for the 20 cups of flour or whatever, you take 1/4 of the 20 and you apply that 1/4 to every ingredient that you're putting in the recipe. You're absolutely right. Now, what about pizza slices? How do you use recipes for dividing pizza slices? So to everyone equally. How would you use that?
Okay. Pizza. Depends on how much slices the pizza got. If it's 8 slices, and it's 8 people, everybody gets a slice.
Well, that means you have to divide the pizza into 8 pieces,
Yeah.
right? You divide the 8 pieces, everybody gets 1/8 of the pizza. Okay.
Yeah.
And of course, it's used in exams, like you have 20 questions on the exam, and sometimes we put the answer. I think I've even given you some of your work back, and I said you got 18 over 20, but you could convert it in a percent, but you can also do it as a fraction. And of course, a half hour is a way of expressing what, 30 minutes. We a lot of time we say, oh, I'll be there about half hour after. And a half hour is half of 60, which is 60
Mm.
minutes and an hour. Okay, so we use fractions all the time. There's nothing new. All right. Now, let me, okay, I want to look at the number line, fractions on a number line. So let me uh, do a new share. And actually, I want to go to the whiteboard. Okay. Now, can you see the whiteboard, Maureen?
Yeah.
Okay. Now, let me just draw. This is a number line. Okay. I want to draw a number line. And it may not be drawn right to scale, but it will be sufficient for what we want to do. So number line, that's one thing I miss about in-person classes, the whiteboard. Lot easier to do it
I
in
know.
person on the whiteboard, with my markers and all for the whiteboard. Now let's draw a number line, and a number line is just a line with 0 in the middle, right? 0. And on the right side, what kind of numbers, Maureen? Over here, what are the signs on the numbers?
Positive numbers.
That's it. Excellent. So plus. And on the left side is negative.
Negative.
That's right. So we have plus on the right, negative on the left. Now we can put numbers here, and I'll just put some numbers here. This is a 1. Right. This is a 2. They're not drawn right to scale, but just so you get an idea of a fraction. So this is a 3, and we'll say a 4. And these are all plus numbers, all right? And 5, and 6, all right? Then on the left side, I want to put negative numbers. So this would be -1 and -2
Mhm.
and -3 -4 5 and not quite the scale. I'll just put a -6. Now, Maureen, I will put a point on this line and I'll call this A. Right? And do that. Okay. And I'll put another point here and I'll call that B. Now, Maureen, tell
Yeah.
me what does A look like to you? What's the value of A between 1 and 2?
Oh, between 1 and 2 is like a half.
That's it, Maureen. Very good. That's 1/2.
Half.
So I'm like midway between 1 and 2. That's a fraction. So between these whole numbers, you have fractions, right? And
Uh-huh.
since I had it like about halfway between 1 and 2, that means that number is 1/2, the fraction 1/2. Now, what about here between 5 and 6? What would you call that point?
A half.
Well, it's past the midpoint.
Um,
So about what would you call it? Give me a number, a fraction.
a third.
What?
Uh,
What did you say?
a third.
Well, now a third would be closer to the 5.
1/4.
No, remember
I don't know.
if the half is midpoint, Maureen,
Uh,
then 1/4 will be like about here.
uh-huh.
In other words, if I took half of a half, I get a fourth. So right here, this would be 1/4. All right. In other words, 1/4 is smaller than a half. So if I was right here on my line, I would be at 1/4. And if I'm here, I'm 1/2. If I'm say like about here, let's do this, then that's about 3/4.
Okay.
I'm getting, so it would be, if I said this is a 1, then that would be 1 and 1/4, 1 and 1/2, 1 and 3/4, which are mixed numbers, right?
Yeah.
So between the number line, I could have between 1 and 2, I could have 1 and 1/4. That's this point. I could have 1 and 1/2, which is the one I call my A, right? So I have
Mhm.
1 and 1/2. And then at this point, I'm closer to my 2, so I have 1 and 3/4. Now, B now is closer to the 6. So what would you call the point B? What would you call this right here?
1/5.
What would you
No.
call it?
1/5.
Well, now remember, I'm between 5 and 6, so it's going to
6.
be 5 and something. So this point
That'd be
would be,
5, 6.
no, these are whole numbers. So this is a 5, this is a 6. Midway would be about 5.5. So this point here is about, well, we'll call this about 3. Well, we'll call this 3/4, right? That's 3/4, but the number is really 5 3/4.
Oh,
5 and 3. It's a mixed number. So so between 1 and 2 is a half, but since this is a 1, if I say what is the value of A, it's 1 1/2. All right, because it's the whole number and then the fraction. Over here, it will be the whole number 5, and then plus the fraction, be a mixed number, because that's what a mixed number is, a whole number and a fraction. So I'm about 3/4 my distance from 5 to 6. So that would be 5 3/4. So you can find your fractions on your number lines. You got it?
yeah.
Now, the same holds for negative. If I had this number, okay, I'm between my -3 and my -4. I'll call this C. What's the value of C, Maureen? Between a -3 and a -4. So what would it be? I know it's a -3, the whole number. What would you call the fraction?
3/4.
No, between -3 and a -4. That's about
Mm.
half, isn't it?
Mm.
This
2,
point, when you
3
say
over 3 over 2.
no, -3 is the whole number.
Mm-hmm.
And between the 3 and the 4, I'm about 1/2. So that would be 3 -3 and 1/2. Okay. Now the way this works, when you're given like on the GED, you may be given a multiple choice with a number line, and they will say point C represent which of these values.
Mm.
Okay, and you pick out the number like here, like this. Okay, let me take here. Let's take another one. Now I'm between 0 and a -1. I call this D. What's the value of D, Maureen?
Half.
Yes, a half, but it'll be a minus, right? It'll be
Yeah,
a
minus.
-1/2. That's right, it's a half. But I'm on the negative side, so it's a -1/2, because I'm midway between 0 and 1. And midway, the midpoint of 0 and a -1 is a -1/2. Got it?
Mhm.
So the number line helps you really understand the fractions, because between each integer, there's a fraction. And later we'll look at decimals and we can convert them to decimals. So because a 1/2 is a 0.5. Okay.
Okay.
Now, let me take one more point. I would say, take this one. Okay. Put it about here. Okay. And I'll call that point E. So what's the value of E, Maureen?
Okay. E would be by the right hand side.
I'm between 3 and 4, and I'm closer to my 3. So what would be the value of E?
1/3. Closer between.
Now, remember, this is a 3.
Uh,
So it's between 3 and 4. So my number is closer to the 3. But anyway, my whole number is 3. What's the fraction?
3/4.
No, 3/4 would be closer to the 4.
Okay.
I think you said 1/3, and which is better
Oh,
because it's smaller than a half. So it could be a third. 1/3. You could call it a third. Could be a fourth also. But anyway, we know it's less than a half because a half is right here. So if I'm moving this way, I'm less than a half. If I'm moving towards the 4, I'm greater than a half, right?
mhm.
So E could be 1/3, or it could be 1/4. So you can recognize fractions on the number line by looking between the whole number, looking between the integers. Integers 3, 4, 4, 5. But between are fractions. But the fraction has to be part of the whole. So every number between 3 and 4 is going to be 3 and some fraction. Got it?
Mhm.
It's like every number between 4 and 5 will be 4 and some fraction.
Oh,
Is that clear on the number line, Maureen?
a little bit. So I would get it though.
Okay. All right, let's just take one more just to make sure. Let me just take another point. I'm between the 4 and the 5, right? And I'll just put here. Okay. And I'll call that F. What's the value of F, Maureen?
1/2.
Remember, I said between 4 and 5, so you're going to
Yeah.
have to have 4 and something. So what would it be? Between 4 and 5 has to be the whole number 4 and a fraction. So what number would I?
4.5.
That's it. Excellent. 4 and 1/2. That's right. Because between 4 and 5, it has to be 4 and a fraction. And it's about halfway between the 4 and a 5. So the fraction will be a half, just like you said. You got it? Is it clear now?
Think so.
Okay, now I am going to save this because I think before I didn't save. Okay. Okay, so it's saved and I can send you this whiteboard. All right.
Okay.
All right. Let's go to a new share and go back to our fractions and mixed numbers. Okay, so we looked at fractions on the number line, and I think I have a number line here. Okay. Now I did it on the whiteboard, but you can see it here. Between 0 and 1, halfway is what? 1/2. Okay.
Mhm.
Between 0 and 1, if they're divided into 5, 1, 2, 3, 4, 5, then that's fifths, right? So
Uh-huh.
this point is about 1/5. This point is 3/5, because each little increment here represents a fifth. So 1/5, 2/5, 3/5, 4/5, 1. And just remember, a fraction is really a division, a number or a variable over a number, a variable. So, and the top part we call what? The numerator, and the denominator we call the bottom part. And that's very important because that's how you uh, do operations on fractions with numerators and denominators. Now I have here, how would you represent 43 over 5 on the number line? Now divide 43 by 5, you get mixed number 8 and 3/5. That means on your number line, the 43 over 5 is found between the 8 and the 9 because it's the mixed number 8 and 3/5. So if I have between 8 and 9 in increments of 5, 1, 2, 3, 4, 5, right? There's my 8. There's my 3/5. So 43 over 5 on the number line would be right here between the 8 and the 9. Mixed number 8. And this point right here would be the 8 and 3/5. Got it?
Mhm.
Okay. See, because we can divide this in equal parts of 5, or we could do 6, we could do 8, but here we have fifths. That means between each increment is 1/5. 1/5, 2/5, 3/5, 4/5. Okay. And you know what a mixed fraction is, right? Sometimes called a mixed number, a whole number and a fraction, right, Maureen?
Mhm. Yeah.
Okay. So we can represent the mixed numbers on the number line. Now, we want to use a pie picture to illustrate fractions. And you see the pizza?
Yeah.
Now, this pizza, there's a whole pizza. We took a part out. What does that look like to you? What fraction does that look like, Maureen?
It look like a half.
That fraction looks like a half to you?
You mean the small one?
Right here. What fraction do you think that is?
Let's see, 1, 2, 3.
What fraction is this slice of pizza right here?
Okay, let me see. 1, 2, 3. A quarter?
That's it, 1/4. Because see, the pizza, and let me just do a new share. Go to the whiteboard. Okay. Let's save that so I can clear. Okay. Now let's just draw a pizza. Okay. Now if I take half of it, I just draw one line, right?
Mhm.
That represents 1/2. But if I take, let me just draw another one over here. And if I take half and then take half of that, then each part there is 1/4.
Mhm.
So that's a fourth, and that's a half. So notice this is a fourth, right?
Mhm.
So 2/4 is the same as a half,
Half, yeah.
right? And if I take the fourth and divide them up, what do I get, Maureen? What if I divide the fourth in half? What do I get?
If you divide the 4 pieces,
The 1/4. What's half? Okay, I've got a half. Then I have a fourth. Now, if I divide these fourths in half, what fraction is that? What
3/4.
no, what fraction right here?
Oh,
What fraction is that? I divide the 1/4 in the half. What fraction is this fraction right here?
1/2.
No, that's a half.
Oh,
That's a fourth.
Uh-huh.
Then I divide the fourths into half of the fourth. So what fraction is this fraction right here? What fraction?
1/4.
That's a fourth. This is smaller than a fourth. What is that? What's half of the 1/4? 1/8, right? That's 1/8. Because look, Maureen, you have 1, 2, 3, 4, 5, 6, 7, 8. So this pizza, this pie is in 8 slices. This is in half. This is in 4. We could call it slices, but this one is in 8 because I took the 4s and divide them into a half, and half of a fourth is 1/8.
Uh-huh.
Yeah, because 2/8. What does that equal to, Maureen?
2/8 is 1/4.
That's it. Very good. 1/4. And that means, there you go, 2/8. Look at these 2 slices here. They're equal to a fourth.
Mm-hmm.
Not drawn exactly the scale, but each of these little sections represent a fourth, and it takes 2/8 to represent a fourth. Just like it takes 2/4 to represent a half.
Mm-hmm.
So using a pie, like a pizza pie, any pie, is a good way of understanding fractions, because you can divide it into half. You got a half. You can divide each half into a half, and you have a fourth. And then you divide each fourth in a half, you got 1/8.
Mm-hmm.
So
And
if
that's what the telling me 1/10, which is 2/5.
what?
Like
What?
how you do the 1/4, you get right, you get 1/8.
How,
If it
how,
was
how do I do what?
no, suppose it was instead of 1/4, right?
Yes.
And it was 1/10. That means that it would be like it'd be like 2/5.
1/10?
Yeah.
No. What are you trying to? If you cut the pizza into 10 slices, each slice is 1/10, right?
Yeah.
Okay, so what are you saying 1/10 is equal to?
1/10 is equals 1/5.
No. 1/5 is equal to 2/10, right? In other words, 2, and look, 2/2 is 1, 10/2 is 5. So 2/10 equal to 1/5.
Okay.
Got it?
Mm-hmm.
Another way of looking at this, 1/5 is 20%, and 2/10 is 20%, right?
Mm-hmm.
They're equal. Okay. Is that clear with the pie, Maureen, the fractions?
Yeah.
Yeah. So if you divide that, if you put it in 8 pieces, then you'll have each piece equal 1/8. So you could give each, say if you have 4 people, you could give each person a fourth. If you have 4 people, a fourth, a fourth. If you have 8 people, you give each person an eighth. So you divide it into 8 pieces. So the whole is then 8/8.
Mm-hmm.
Whereas the whole here is 4/4. The whole here is 2/2. They all equal to 1.
Uh-huh.
Got it?
Okay. Mm-hmm.
All right, we're gonna save that. Okay. Let's go to a new share. Go back to Okay, so back to the pizza. So you said that's a fourth and that's a fourth. But just like we have the fourth, we could divide this into half and that would be what? 1/8. So we could really cut that pizza so that we get 8 slices. So each person, if it's 8 people, would get 1/8 of a slice, a smaller piece. Okay.
Yeah.
Okay, now let's look at our next. Okay. Maureen, read number 1, an example.
These are 2 slices of pizza. Yeah, there's 2 pieces.
Keep going.
Or John ate 3 slices of pizza. If there were initially 8 slices of pizza, how many slices of pizza were left? 8 of 8 whole 8 of 8 whole pizzas.
Hmm. So you have 8 equal slices.
Mhm.
Lisa ate 2.
And
Juan ate
one ate
3. That's a
3,
total of how many slices?
5.
5. Okay. And then you have a total of 8 slices. So 5
Mhm.
from 8 is what?
It's 3.
Yeah. Now, since 8 slices, your denominator is 8, right?
Mhm.
So the number of slices left would be 3/8.
Yeah.
5/8 is the fraction that was eaten by Lisa and John. Okay.
Uh-huh.
So 5/8 plus 3/8 is equal to the whole pizza,
Mhm.
right? So what they ate plus what is left would be the whole pizza, which is an
Uh-huh.
eighth, and we call it 8/8.
Mm.
Got it?
Yeah.
Okay. Maureen, I want you to solve this next problem. Let's see. Okay. Read it and tell me what is the answer.
Brandon's birthday cake has 15 equal slices. He gave his friend 8 slices of the cake. He gave his teacher 3 slices of the cake. What is the fraction of the cake did he give away?
So what fraction would you say? The whole is 15 slices. So that means the denominator is 15, right?
Yeah.
So
Uh-huh.
how much did he give away as a fraction?
11 over 15.
That's it. Excellent. You add up what he gave to the friends plus what he gave to his teachers, 8 plus 3. Put that number over the denominator, which is the 15, and you get 11 over 15. So tell me in words what you did, Maureen.
Huh?
Tell me, tell me what to write. I want to write what you just told me, which is correct, but tell me what to write.
I said he gave his friend 8 slices of the cake,
Okay.
and he gave his teacher 3 slices of the same cake.
So what's the total that he gave away?
11.
Okay, right. So 8 slices
Okay.
plus 3 slices equal
It was
11
11.
slices. Okay. So he gave 11 slices. So the fraction given is 11 over 15. That's it. So he gave 11 over 15 fraction of his cake. So how much did he keep?
4.
That's it. 4 over 15, right?
Yeah.
There was a fraction kept by Brandon is 4/15. Okay. So he gave away 11/15. 11/15 plus 4/15 equal 15/15, which is the whole cake. All right. Now, let's look at how we simplify fractions. We sometimes call it reducing to the lowest terms. Now, there are different ways of doing it, and we'll do some ways of doing it, but I think I'll let you decide how you want to do it, because sometimes you can do it with mental math. Like Maureen, if you had to reduce 9/12 to its lowest term, how would you do it?
If I had to reduce 9 of the 12,
Yes. If you had to reduce this to the lowest term, reduce 9/12 to its lowest term.
okay.
Now, we could use the greatest common factor, but sometimes you don't really have to do that. Now, I illustrated here that you could do it and come up with the 3 as your greatest common factor. This in common with the 9 and 12, and you get the 3/4. But
Yeah.
sometimes you know the factors without doing that. So how would you reduce 9/12? Tell me, what method would you use?
Oh, I would do 3 and I would do 3 and 4. Or
You would do what?
it's like 3 to 9 is 3,
Right?
and 3 to 12 is 4.
Okay, that's good. So you just did a mental math. So I'm just saying there are different ways of doing these things, and I think uh, you should do the way that you comfortable with. Now, you really just use mental math. Using mental math,
Mhm.
9/3 and 12/3 gives 3/4. So that's perfectly fine, because sometimes the numbers are numbers you're familiar with and you know what the factors are.
Mhm.
And that's what you just did, and that's fine. Now, 14/35. Tell me what answer you get with that one.
14 over 35.
Yes, reduce it to its simplest terms. What do you get?
Okay. I get 2 and 7.
You get one.
2 into 14 is 7. And 7 into 35 is 5.
You mean 7/14.
7 into 14 is
You
2.
have
Yeah.
to, because you'd have to divide the number into both numbers. So 2 doesn't go into 35. So, okay. So using, there again, you use mental math.
7 into 14. Yeah.
Okay. 14 divided by 7 and 35 divided
Divided by 7.
by 7 gives, so what's the answer?
7.
14 over gives 1.
14 give you 7. Let's see.
14 divided by 7 is what?
It's 2.
Is 2.
Yeah.
35 divided by 7 is what?
5.
5. So it gives you 2/5. Because if you multiply 7 by the numerator, 2, you get 14, and 7 by the denominator, 5 gives 35. Okay, so you can use method math and get it. Now, sometimes you may want to use your greatest common factor if it's numbers that maybe you can't see the factors, okay? But the quickest way is the way you're doing it. Just use method math, being familiar with the numbers themselves and their factors, and that's the way you could do it, okay? What about 15 over 8, Maureen? What would you get for that one?
15 over 8.
Yeah, we wanna simplify that. Let me,
Okay.
how would you simplify that?
I would say, okay.
I
That
give
become
you
like
a, I give you a hint. When you
that become
have,
like that become like a mixed factor, right?
oh, that's right, you're gonna have a mixed fraction, because whenever your numerator is greater than your denominator, then you're gonna convert it to a mixed fraction. So what would it be then? What would be the answer?
8.
15 divided by 8 is what number? Fifteen over 8
15
is,
divided by 8 come out to 1.875.
well, no, we're not doing decimals yet now. We're still doing fractions. Is now, whenever your numerator is greater than your denominator, we have what we call an improper fraction. So 15 over 8 is an
It's 8 ones is 8,
improper.
and 7 is 15.
So what's the answer?
1 and 7 is?
That's it. To a mixed number. Okay, so 15 over 8 equal 1/7/8. Because 15 divided by 8 is 1, and then you have a remainder of 7, and that 7 you put over the denominator, so 7 over 8. That would be the answer. Okay, Maureen, you have a really good handle on that. Okay, what about 4 over 9?
Okay. 4 twos is 8, and 1 is 9. So that'd be 2 and 1/4.
4 over 9?
You divide.
You simplifying 4 over 9. What would be the answer?
It divide 4 into 9, right? 4
No,
twos is
you're trying to simplify it to a fraction, Maureen. Because you divide 4 by 9, you're going to get a decimal. So what would you get for the simplification of 4 over 9? How would you reduce it to its lowest term?
okay. 4 twos is 8, and 1 is 9.
Why are you adding 1? Remember, when you simplified, you divided both the numerator and the denominator by the same number. But you can't do that here, because there's no number you can divide 4 by and divide 9 by and get whole numbers. So what would you do for 4/9? Okay, let's do this. Okay, factors of 4. What are factors of 4?
1 and 2,
1, 2, and what else?
and 4.
And 4. That's right. Remember, you always start with 1 and with 4. Now you have 2 in between. Now let's do the factors of 9.
1,
Okay, so we have 1. What else?
3,
3. What else?
9.
9. That's it. Now, what factors do they have in common?
1,
Common factor is 1. So whenever the common factor is 1, the number is already at its lowest terms. Okay, so the common factor is 1, so you can't reduce. Okay, so for nice can be reduced. It's already simplified. Okay,
uh-huh.
so whenever you get a common factor of 1, then whatever fraction you have, it cannot be reduced. It's already at its simplest form.
Okay.
Okay, it's already at its simplest form. Got it?
Yeah.
Okay. All right. So that's one where you can't really simplify it.
Oh,
So because the greatest common factor is a 1, which I have right here. And like we said, the factors are 1 and 1, 2, and 4, and 1, 3, and 9. And the only ones they have in common is the 1. So let me take it out. So whatever your greatest common factor is 1, your fraction cannot be reduced. So 4/9 is as simplest as it can get.
okay.
Got it?
Yeah.
Okay. All right, let's just take that out. What about, okay, Maureen, I've got, that was D. Now let's go to E. Simplify that one for me, Maureen.
Okay.
8/52, Maureen. I want you to simplify that.
So we say a 1, right?
Well, okay.
1.
Now, are you going to use mental math or you're going to do the common factors?
Okay.
How would you do this one? Are you going to do mental math or you're going to list the factors?
I was gonna list the factors.
Okay, all right. So let's start with 8. Factors of 8. Or, so what are the factors of 8?
1,
1,
2,
2,
4,
4,
and 8.
and 8. Very good. Okay. Now let's list the factors of 82. Factors of, I'm sorry, 52.
52.
52 are, so what are the factors of 52?
1.
We know we have a 1. What else?
Okay. Let's see.
What about 2?
2.
2.
let's see, 3,
3. Okay.
4,
4. What else?
52. Can't be 5.
Well, it can't be 5. Yeah, well, let me put, well, we know 52 is one of them because I always put 1 and the number will be in
Yeah.
factor. Anything in between?
4.
We've got 4. Anything else?
Or 5.
5 won't go into 52 without a
I
remainder.
remember. No, 6.
6 goes into 52? No,
No. Not 7.
that's right.
Not 8. Not 9. 52.
You've got 52. Anything else?
Let me see. 5. No. I don't think so.
There's another one. 4 times what number gives 52?
Oh, let's see.
52 divided by 4 is what?
14.
14 times? No, that's 56.
No.
13.
30. Yeah.
4 times 13 is 52.
Yeah. Oh yeah.
Okay. So what factors do they have in common?
4.
Now these two lists, the common factors, the ones you see in both lists are what? 1, 2, and 4, right?
4. Yeah.
Common factors are 1, 2, and 4. Now, what's the greatest common factor of that list?
Which one? The 52.
1, 2, and 4. No, these are the
8. 8.
no. 1, 2, and 4. 1,
Yeah.
2, and 4. Those are factors that are common to both lists. The factors of 8 and the factors of 52. Now, what is greater, 1, 2, or 4?
4.
4. So that's our greatest common factor. So now take that and divide that into 8 and 52. And what do you get?
Oh, 2.
That's right.
Right.
Yep, 2.
And
So,
13.
okay, so we have 8 divided by 4.
It's 2.
Yeah, let me put that underneath this. Okay. 8 divided by 4, and then we've got 52 divided by 4.
4.
Let me get rid of that on the line. Bring that up so you see it's numerator over denominator. Okay, so what's 8 divided by 4, Maureen?
2.
Okay, so that's equal to 2. And what's 52 divided by 4?
13.
13. So you have 2 prime numbers, so you know that's the simplification. Okay, let me just get rid of that on the line right there. So 8 over 52 is 2 over 13. That's the answer. Got it?
Yeah.
Now, this is one now where you did the factoring, define it, the factors of both, and then the common factors, and then the greatest common factor. And that greatest common factor was a divisor into numerator and the denominator to give you the simplest form. Do the next one, Maureen. I want you to do that one. 96 and 144. Tell me what you get. Give you a few minutes to do that one. 96 and 144. Reduce to the lowest terms.
So I could divide 96 by 144, right?
No, that's going to give you a decimal. You got to find your factors, Maureen.
Or doing factors.
Remember, Remember, we are reducing these fractions to their lowest terms.
Okay.
And we're using either finding the greatest common factor
So we gotta do
or
96. 96 and 1. Right? 96 and 1. 96 and 1.
So you're gonna do factors
Ouch.
of 96. Or now you're gonna have 1 and then 96 and then in between. All right. And then you're gonna do the same for the 144. Factors of 144. And you'll start with 1.
Yeah.
And you'll end with 144. And then put the ones in between.
So it's 96 and 1.
So list your factors between 1 and 96, and also your factors between 1 and 144. What are your factors?
Okay, 1 and 96. 2.
Okay. So you have 2. Anything else?
2, 142. 2, yeah. Okay. 3.
Okay, 3.
Okay. Yeah, how much is 4? 96. Okay, 96 at the end.
Yeah, we got 96 at the end. What comes after 3?
Okay. 4.
4.
No. 1, 2, 3, 4, 96. Let me see, 5. What number can multiply by 4 to get 96? I don't know. 4 14s. Okay.
What comes after 4?
6.
6.
5, let's see. 6. 16s is 96. Yeah.
What comes after 6?
Okay, I'm trying to tell you now. 6. Okay, let me see. 1, 2, 3, 6.
What about 8?
Okay. Yeah, 12 X is 96.
Okay, so 8 would be 1, right? 8.
Yeah.
Anything else?
8, 12 is 96.
So 12 would be 1, right?
Yeah, 12 is 1.
Anything else?
5x is 96. Let's see. I don't think so. Just
16?
be 96.
No, what about 16? 16? What's 6 times 16? Isn't that
Oh,
96?
90, yeah, 96, yeah.
Anything else?
It's 96. Okay. Let's see.
Anything else?
No, I just be 96. So let's see. 16 is 96. Let me see. 17, 18.
Well, we know 24 is one of them because half of 48 is 24, right?
Mm-hmm.
32, we know is one. And 48, we know is one, half of it,
Mm-hmm. You're right.
right?
Mm-hmm.
Okay. So those are some factors of 96. Okay. Let's look at some factors of 144. Now we know 1 and 144.
Mm-hmm.
What's the next one?
2,
2. Okay. What else?
4.
4 goes into 144? I don't think so.
Oh.
Oh, yes, it does. Okay, 4. What else? 6.
How is 3?
3 doesn't go into 144. A 3. Oh, yes, it does.
Yeah, call 3. Yeah, call
Yeah,
3.
yeah, it would be a 3.
Yeah, 1, 2,
3.
3, 4, 6.
1, 2, 3, 4, 6. Anything else?
Okay.
Well, 9.
How is 8?
I don't think 8 would work.
I mean 18.
Let's see.
It's
8.
8. 8.
Yeah, 8, 8, 6, 8 and 9. Right?
Yeah.
Yeah, 8, 9. What else? Well, we know 12. 12 times 12
Yeah.
is 144. So 12. Anything else?
I just the 144. Let me see.
Nothing else? 16 would also work. 16. Anything else?
Let's see. I
18,
got it. Huh?
18.
Yeah. Got 18 into 144 is 8.
Anything else?
Okay. Ouch.
24, I think would work.
Yeah, cause 124. What is the 6? Yeah, cause 24 into 144 is 6.
Well, we know that would work, right?
Yeah. Okay.
And we know 48 would work.
Uh-huh.
Because see, you can multiply some of these
Uh-huh.
numbers and they would work.
Mm-hmm.
Okay. So we have 48. We have,
Mm-hmm.
I know 72 is one, because
Oh,
that's half of it, right?
yeah. Mm-hmm.
Okay. Now, what's the greatest common factor? I think we have enough of them here. Now you see what they have in common, right?
Mm-hmm.
Common are 1, 2, 3, 4, 6, 8, 12, 24, 48. Okay, so you see the common factors and which one is the greatest? Okay, what are the
Greatest is 48.
common factors? Okay, so the ones they have in common are what? 1, 2, 3, 4,
4, 6,
6, 8, 12,
5, 16,
16,
24,
24.
and 48.
Okay, 48. That's it for the common ones, right? And what's
Mm-hmm.
the greatest of those? 48, right?
48. Yeah.
So the greatest common factor, GCF equal 48. So now divide the 48 into 96 over 144, and what do you get?
96 into 48.
Well, divide 96 by 48. So you'd have 96 divided by 48. Let's put my slash here
It's
and
2.
underline that. That's right, that's 2 there. That's a prime number. Okay. And you're dividing that by 144 divided by 48. What does that give you, Maureen?
Okay. 144 by
Underline.
the by 48. 3.
Okay. So the top one you get what?
2, I think.
That would be
Yeah.
2. Okay.
Yeah, it was
And
3.
and then the 3. That's right. And that would be the simplification
Okay.
or reduce to the lowest term. So that would be 3. So 96 over 144 reduced to the lowest terms of 2/3, 2 over 3.
Mm-hmm.
Okay.
Mm-hmm.
Now, right up here when we were doing our factors, Maureen, once you get these lower numbers and you start getting these, see 6 times 3, 18, that's a factor. 4 times 4 is 16, right? 6
Mm-hmm.
times 4 is 24, that's a factor.
4.
See, when you multiply these, you get factors.
Uh,
6 times 8 is
uh,
48. 8
uh,
times 9 is 72. So once
uh,
you get your first, you can multiply some of those and they will be factors also. So you don't have to go through trying to figure them all out. Once you get some of them, you can just multiply. 6 times 4, 24. 6 times 3, 18. 4 times 4, 16. 2 times, 6 times 8, 48. 8 times 9, 72. Or you could take half of 144, that's 72. 72 times 2 are factors, right?
Yeah.
So the 96 over 144 can be simplified to 2 over 3.
Mm-hmm.
All right. Now, I think I'll give you probably these as word problems. Okay. And then we'll start with addition, subtraction, multiplication, division of fractions. Now, these last ones, Maureen, simplifying fractions and word problems. I will give you this as homework. Okay. Where you read it, determine the fraction.
Okay.
Okay. Now, it's a multiple choice. Simplify your answer. Reduce to the lowest terms. That's goes with the word problem here. And then here, you're going to come up with a fraction. You're going to put the numerator here, the denominator here. And we'll start with the addition, subtraction, multiplication, and division of fractions next time.
Okay.
Maureen, you did really good. I'm sorry you didn't get any of your other people joining. I don't know what happened to Vanessa. She was supposed to be on. But I don't know what happened. But you did good. So, but now let me emphasize to you that if you can do these with the mental math, do that.
Okay.
Use the factoring when you can't do it with your mental math, because it will be faster. Okay.
Okay.
Okay, so I will see you the next time.
Okay, thanks.
Okay, so I will send you the session and I will separate out the homework. The homework will really be these two problems, actually, these two word problems. Okay, that would be your homework. Okay.
Okay. All right.
All right. So long. Thanks.
Okay. Bye-bye.
Bye-bye.
Yeah.